Good afternoon, everyone. Before I start this presentation, I would like to thank the CAR organization for making this event possible, despite the difficult times we know today. For this talk, I don't have any conflict of interest to disclose. My presentation will focus on the impact of early antiretroviral therapy on B and CD4 T cell dynamics in lymphoid tissues of SIV-infected Rhesus macaques. As you know, HIV infection is associated with an early viral dissemination, a peak of viral load during the first weeks post-infection, and a depletion of CD4 T cells in the blood. Recently, in SIV-infected Rhesus macaques, previous studies in the laboratory demonstrate an early loss of CD4 T cells in lymphoid organ, as peripheral lymph nodes, spleen, and mesenteric lymph nodes. Here, each dot represents one individual at several times post-infection, 2 weeks, 4 weeks, and more than 8 weeks post-infection. Furthermore, for the same animals, as described before, we demonstrated that follicular T helper cells, or TFH, a subset of CD4 T cells that are essential for B cells maturation and humoral response, is also decreased in lymphoid tissues, especially in the spleen, and mesenteric lymph nodes during SIV infection. As you know, despite the administration of early antiretroviral therapy, ART, a viral rebound is observed after ART interruption. Herein, treatment administered at day 3 or at day 7 controls the viremia. Nevertheless, a rebound is observed after the treatment interruption. This demonstrates the presence of viral reservoirs in deep tissues as lymphoid organs despite early ART. Therefore, is there any impact of viral reservoirs in deep tissues under ART on B and CD4 T cell dynamics? To answer this question, we have addressed the B and CD4 T cell dynamics under ART in SIV-infected Rhesus macaques. We use SIV-infected monkeys, daily treated with a cocktail of antiretroviral drugs at day 4 until 55 days post-infection, corresponding of 7 weeks of treatment. Animals were sacrificed under ART, and blood, peripheral lymph nodes, spleen, and mesenteric lymph nodes were recovered. During the time of infection, we also monitored viral loads. As shown here, we demonstrate that the administration of antiretroviral therapy at day 4 drastically reduced the extent of viral load, decreasing from 10 to the 6 to 10 to the 8 to less than 10 to the 2 to 10 to the 3 copies per ml. More importantly, all the treated monkeys had undetectable viral load at day 55. Next, we analyzed in treated and untreated animals the dynamic of CD4 T cells by flow cytometry analysis. We provide evidences that early ART prevents the CD4 depletion both in the blood, the peripheral lymph nodes, as well in the spleen and mesenteric lymph nodes. Nevertheless, the percentage of CD4 T cells is lower in several treated Rhesus macaques. Furthermore, the analysis of CD4 and CD8 ratio indicate that the ratio remains lower in the spleen and mesenteric lymph nodes in half of the treated animals. By flow cytometry, we define the different CD4 T cell subset: naive, central memory, effector memory, and terminal differentiated T cells. And we found that early ART prevents the change of the central memory effector memory ratio. Nevertheless, we observed that early ART has a minor impact in peripheral lymph nodes on central memory and effector memory ratio. We then analyze TFH cells characterized by double expression of CXCR5 and PD1, and we demonstrate that early ART prevents the depletion of TFH cells from the spleen and mesenteric lymph nodes in half of treated monkeys. In contrary, early ART increases the percentage of TFH cells in the blood and in the peripheral lymph nodes early after treatment. In another hand, despite ART therapy, we observe that the percentage of CD4 T cells expressing PD-1 are increased both in lymphoid organs as well in the blood compared to healthy monkeys or non-treated SIV-infected monkeys. Altogether, this may be indicative that abnormal immune activation is occurring in ART-treated animals. Then we analyzed the dynamic of B cell by flow cytometry, and we found a depletion of B cells in the blood during the acute phase, consistent with previous reports. However, we found an increase of the proportion of B cells in lymphoid tissues in SIV-infected monkeys, which is prevented by an early antiretroviral therapy. We then analyzed by flow cytometry the percentage of B cell subsets, including naive and activated memory cells. Herein, we observed an increase of naive B cells at week 8 post-infection in the blood, which is prevented by ART. Concomitantly, we observed a decrease of activated memory cells, which is also prevented by the therapy. In peripheral lymphoid nodes, we observe that early ART increases the percentage of activated memory cells. In contrary, in the spleen and mesenteric lymph nodes, we observe that the decrease of activated memory cells is not totally prevented under ART. In particular, in the spleen, we observe a higher level of naive cells under ART than healthy monkeys. To conclude, my work has demonstrated that early ART prevents the CD4 T cells depletion both in the blood, peripheral lymph nodes, the spleen, and mesenteric lymph nodes, but partially restores the CD4 and CD8 ratio. We showed that TFH cells are partially restored in the spleen and mesenteric lymph nodes under ART, and that the CD4 T cells expressing PD-1 receptors are expanded in the spleen and mesenteric lymph nodes under the therapy. Finally, we found that ART prevents B cell expansion. In contrast, in the spleen and mesenteric lymph nodes, activated memory cells remain lower in animals in which TFH cells are lower. Altogether, our data demonstrate persistent B and T cell abnormalities despite early ART. To finish this presentation, I would like to thank my research director, Dr. Jérôme Estaquier, and the lab team who help me every day, and the collaborators. And finally, I thank all the monkeys without whom all this work would not have been possible. For any question, you can contact me at the email that appears in the slide. Thank you for listening and have a good day.